Okay, this is problem 21 to 25. This is now the third time I've recorded this video. If it doesn't work this time, I'm not doing it again. Alright, 21. It says, find whether this geometric series converges or not. So what it means to converge is, if you thought of the graph and it started at 2, which it does start at 2, that's the first term. Does it come down and eventually level off at some answer or some number like 0, right? Does it converge? Does it eventually get smaller and smaller and smaller, but eventually it just gets to an answer of like 0, for example? Or does it come down and maybe level off at the number 1? Okay, converging is it basically reaches a point where it doesn't get any smaller and levels off as it approaches 11. Okay? Or, contrary to that, it could diverge, which would be it would start here and it maybe go up forever and it get bigger and bigger and bigger and bigger. The only way you can tell that is by looking at the equation. Because this is 1.3, that's a common ratio that we talked about in class. That number is bigger than 1. That R value is bigger than 1. That means it's going to grow, 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 grow. And because it's going to grow, it's not going to converge, it's going to actually diverge. So for something to converge, you want it to be between the numbers 0 and 1, the common ratio. Be like 1/2 or 0.5, right? That would make it kind of like it's smaller, 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 and converge. So this problem, the answer is no, it does not converge. On to the next one. The next one wants us to actually find the partial sum of this sequence here, but you don't know what it is. And the reason it's a partial sum is because it goes from 1 to 5, not 1 to infinity. And what I do know about this equation, what you need to know, is this is the first term, and this is the common ratio. And when you see an X on it, you know it's a geometric sequence. This is a partial sum of a geometric sequence, or series. Okay, and the formula we need is this. U sub 1 times 1 minus r to the n, all over 1 minus r. That's the formula we're going to use to find the partial sum. So let's put in the numbers we know. U sub 1 is 3. R is 2. Excuse me. And the number of terms is from 1 to 5. There's 5 terms. All over 1 minus r, or 1 minus 2 again. Okay? So now we just have to do that on the calculator. So we will plug in all our numbers. So that's 3 times 1 minus 2 to the 5th. Okay. Divided by 1 minus 2. You get 93, that's the answer. So the sum is 93, this geometric sequence. Okay, the next one is also wanting you to find the sum, but it's written in different notations. It's S sub 4. Sum up the first 4 terms. Now this doesn't have any exponents, this little equation. No exponents. There's no exponents. I think it's probably not a geometric sequence. So it's probably arithmetic. So this is the partial sum of an arithmetic sequence. Okay, and that formula looks like this. So we're going to do S sub 4. We need to know the number of terms, the first term, the last term, divided by 2. So I'll write that down. This is the first term. This is the last term. And this is the number of terms right here. Now, this problem's a little bit harder because they don't actually tell you the first term. They do tell you there's 4 terms. The first term, you need to go and put a 1 in right at the beginning up on the equation up here. 2 times 1 minus 1. 2 times 1 minus 1 is just 1. Plus the u sub n. The last term will be the 4th term in the sequence. You'd have to put a 4 in. 2 times 4 is 8, minus 1 is 7. Okay? And that's everything you need to find the sum. You calculate all that, which we can do in our head. 1 plus 7 is 8, times 4 is 32, divided by 2 is 16. So you may have to rewind that and listen to it again, but the answer is 16. Okay? And number 24 wants us to make a box plot. So to do that, we're going to mostly just use our calculator. And what I want you to do is turn it on. You need a number line on your paper, but on your calculator, turn it on, hit the stat button, and hit edit. Enter. And under list 1, if there's a lot of junk in there, a lot of old stuff, go up to highlight right where the box, so it's blacked out on 1, hit clear down. I'm not going to do that because I've already pre-entered all my data here. So you take a minute to enter yours in. Maybe hit pause. Okay, then after it's all entered, hit stat, scroll over to calculate, 1 variable statistics, and hit enter. And it gives you all this important information, but the stuff you need to make a box plot is down below. Okay? It says the min is 0, and the quartile 1 is 3, and the median is 6, and the quartile 3 is 8, and the max is 14. So we need a whisker from 0 to 3. Box and whisker. So there you go, from 0 to 3 is the beginning of the box. And the box goes all the way over to quartile 3, which is at 8. And the median is a little line down through the box at 6. And then the max should be the whisker all the way up to 14. It's a box and whisker plot. This is Q3, the upper quartile. This is Q1, the lower quartile. This would be the min, and this is the max. And this is the median. We cut all that off the calculator. The other thing the calculator can do is actually graph this itself. So if you go to second stat plot, and you turn on this plot, and you go to the type that you can see I've highlighted already, and just hit zoom, number 9 for statistical plot, it will graph it. Just like that. And you hit trace, and it brings the cursor up on the min, and as you hit to the right, it travels to quartile 1, to median, to quartile 3, or upper quartile, and the max. And that's it for this video. Number 25 is part of this video, but we just answered all the questions for 25.